We now learn how to add and subtract with complex numbers. And for that, we're going to work through the exercise that we see here, in which we have to answer 4 short questions. To get us started, let me move this question to the side. There we go. To add and subtract any two complex numbers, we need to use the following rules. Given a complex number z1, which equals to a plus ib, as well as a second complex number, which I'll call z2, which equals to c plus id, the sum of these two complex numbers, so z1 plus z2, is in turn another complex number whose real part is equal to the sum of the real parts of z1 and z2, in other words a plus c, and whose imaginary part is the sum of the imaginary parts of z1 and z2, so that's b plus d. In other words, z1 plus z2 is equal to a plus c plus I times b plus d. And we define subtraction in a similar way. Indeed, z1 minus z2 is equal to the new complex number whose real part is equal to the real part of z1 minus the real part of z2, and whose imaginary part is equal to the imaginary part of z1 minus the imaginary part of z2. In other words, z1 minus z2 is equal to a minus c plus I times b minus d. Alright, now that we've established the rules, let's go ahead and work through the exercise that we have here. So the first question we have is question A. And in question A, we need to find z1 plus z2, where z1 is the complex number 2 plus 3i, and z2 is the complex number 6 plus 4i. And we can write this as follows. z1 plus z2 equals to 2 plus 3i, that's z1, plus z2, which is 6 plus 4i. Now, to add these two complex numbers, all we have to do is gather like terms. In other words, we gather the two real parts, that's 2 and 6, and we gather the imaginary parts. So that's equal to 2 plus 6, which is 8, plus 3i plus 4i, which is 7i. And that's the answer. We move on to question B, and in question B, we need to find z1 minus z2. So let me just write that. That's question B. We need to find z1 minus z2. Well, that's equal to z1, which is 2 plus 3i, minus z2, which I write in parentheses. So that's minus 6 plus 4i. Careful, when subtracting one complex number from another, do make sure to write parentheses to avoid making sign errors. So opening up the parentheses, that leads us to 2 plus 3i minus 6 minus 4i. I now gather like terms, in other words, the real parts together and the imaginary parts together. So that leads us to 2 minus 6, which is negative 4, that's the real part, and 3i minus 4i, which is negative I, and that's the imaginary part. And that's the answer. We move on to question C, and in question C we need to calculate z2 plus z3, where z2 is still 6 plus 4i, and z3 is equal to 5i. In other words, z3 is purely imaginary. So we write z2 plus z3 equals to 6 plus 4i, that's z2, plus 5i, which is z3. Now, although z3 doesn't have any real part, in other words, its real part is equal to 0, we still calculate this in the same way. In other words, we gather like terms. So the real part of the result will simply be 6, and I add to that 4i plus 5i, which is 9i. And that's the answer. Finally, we move on to question D, and in question D we need to find z4 minus z1. And we can see that z4 is equal to 7. In other words, its imaginary part equals to 0. And z1 is still 2 plus 3i. So this will equal to 7 minus 2 plus 3i, which I write in parentheses. Now opening up those parentheses leads to 7 minus 2 minus 3i. Finally, gathering like terms, we find that this equals to 7 minus 2, which is 5, minus 3i. And that's the final answer. And so that's how we can both add and subtract with complex numbers. And that's it for this tutorial.